Bismillahirrahmanirrahim. Nahmaduhu nasalli ala rasulil kareem. Dear students, the second topic of our next chapter is the Bronsted-Lowry concept of acid and bases. In previous lecture, we have studied about the Arrhenius concept of acid and bases. So, in Arrhenius theory, there were some limitations that it applies to aqueous solution, which means that it requires water as a medium. Without water, we cannot detect a substance to be an acid or basis. It requires uh, aqueous solution as compulsory substance, as compulsory medium. The second limitation was that it doesn't explain why compounds such as carbon dioxide, sulfur dioxide, etc. are acids. There are other examples uh, besides carbon dioxide and sulfur dioxide which do not contain any H positive ions, any proton. So how can we identify these substances whether they are acids or bases, as they don't have H positive or OH negative ions? Similarly, NH3 is base, but Arrhenius cannot explain why it is base, as there is no OH negative hydroxyl ion in NH3. So these limitations were removed by Bronsted and Lowry. In 1923, J. N. Bronsted and T. M. Lowry independently proposed another theory to overcome the shortcomings, to overcome the limitations of Arrhenius theory. According to this theory, an acid is a proton donor and a base is proton acceptor. Here on the reactant side, acid donates proton to a base. Is the simple schematic diagram that acid would be a substance that would donate a proton to a base. Let's take a look on an example that HCl. We know that HCl is an acid. So Bronsted-Lowry explained this as HCl is a substance that donates its proton to another substance. Similarly, H2O here acts as a base because it accepts protons from acid. In the reactant side, HCl has one proton, and on the product side, Cl negative has no proton, which means that it has donated a proton. In the reactant side, H2O has two protons. Here when we expand the structure formula, that H2O has two protons, but on the product side H2O has three protons. It has accepted one proton from HCl, so it has donated proton to so according to the Bronsted-Lowry theory, it is a base. H2O here acts as a base. So the substance that donates proton is known as an acid, and the substance that accepts proton is known as an acid. Proton is basically H positive, hydrogen with no electron. Another example is that of sulfuric acid and water. Sulfuric acid, here on the reactant side, sulfuric acid has two protons, but on the product side, bisulfate ion has only one proton, which means that it has lost one proton. H2O on the left side has two protons, and on the right side it has three protons, which means that it has gained one proton. So the substance that donates or loses protons is known as an acid, and the substance that accepts proton is known as a base. Okay, you have to tell me in this reaction which substance acts as an acid and which substance acts as a base. Here is another example, NH3. The in Arrhenius theory, Arrhenius doesn't identify NH3 whether it is an acid or base. But in Bronsted-Lowry concept, we can easily identify NH3 as a base because it has accepted one proton. NH3 on the left side, it has three protons, and on the right side, when it forms ammonium ion, it has four protons, which means that it has gained one proton from H2O, and H2O On the left side it has two protons, and on the right side hydroxyl ion has only one proton, which means that H2O has lost its proton. So NH3 here acts as a base and H2O acts as an acid. The substance that accepts proton acts as a base, and the substance that donates proton acts as an acid. So here ammonia is a base and water acts as an acid. All the acids included in the Arrhenius theory are also acids in Bronsted-Lowry theory. However, all the bases included in Bronsted-Lowry theory except OH negative ions are not Arrhenius bases, which means that the acids that were explained in Arrhenius theory are also acids in Bronsted-Lowry theory. But all the bases having OH ion that are explained in Arrhenius theory may or may not be explained in Bronsted-Lowry theory. All bases included in Bronsted theory except OH ions are not Arrhenius bases, which means that let's take an example of the above reaction. NH3 has no OH ions, so NH3 is base according to Bronsted-Lowry theory, but NH3 cannot be classified as a base according to Arrhenius theory. So all the bases included in Bronsted-Lowry theory except OH ion are not Arrhenius bases. NH3 is not Arrhenius base because it has no OH ion. But as it accepts a proton, so it is base according to Bronsted-Lowry concept. Take two examples. HCl plus H2O, I have already told you. Similarly, NH3 when react with water to form ammonium ion and hydroxyl ion. In the first reaction, H2O accepts a proton to form H3O positive, which means that it is a base. But in another reaction, H2O loses a proton to form hydroxyl ion, which means in this reaction it acts as a base. HCl is acid, NH3 is base. H2O can react with acid as well as base. So substances that react with both acids and bases are called amphoteric substances. H2O is amphoteric species or amphoteric substance because it can react with acid as well as base. When it reacts with acid, it can accept proton, and when it reacts with base like NH3, it can donate a proton. So it acts as both an acid and base, and this substance and such substance is known as amphoteric substance. Science, society and technology. Fossil fuels contain small amount of sulfur and nitrogen. They produce sulfur dioxide and oxides of nitrogen when the fuel is burned. Large amount of these oxides are released from coal burning factories and power stations. They react chemically with water vapors in clouds and oxygen in the air, forming acid. Like sulfur dioxide emitting from fossil fuels, emitting from cars, emitting from vehicles that burn fossil fuels. Similarly, nitrogen dioxide emitting from factories and vehicles that burn fossil fuels. When the sulfur dioxide and nitrogen dioxide react with oxygen and water vapors in the rain, in the clouds, or in the moisture of atmosphere, they form sulfuric acid and nitric acid. These acid mix up with raindrops and fall as acid rain or acid snow. ओके रसूलुल्लाह सल्लल्लाहु अलैहि वसल्लम ने फरमाया, जिसने रोज़ा रख कर भी बदजुबानी और झूठ ना छोड़ा तो अल्लाह ताला उसको उसका खाना पीना छोड़ देने की कोई ज़रूरत नहीं. ओके, रिमेंबर मी इन योर प्रेयर्स. टेक केयर. Allah Hafiz. Thank you so much. If there is any question, you can ask me